Behavioral Neuroscience, Chapter 3, Segment 2. An action potential is the propagated electrical message of a neuron that travels along the axon to the presynaptic axon terminals. Hyperpolarization is an increase in membrane potential. The interior of the neuron becomes even more negative. Depolarization is a reduction in membrane potential. The interior of the neuron becomes less negative. Capacitance is the membrane's ability to store electrical charge. A neuron's change in potential is called a graded response. The greater the stimulus, the greater the response. Local potential is an electrical potential that is initiated by stimulation at a specific site, which is a graded response that spreads passively across the cell membrane, decreasing in strength with time and distance. A threshold is the stimulus intensity that is just adequate to trigger an action potential. It is positive relative to the outside of the cell. The all or none property is the fact that the amplitude of the action potential is independent of the magnitude of the stimulus. Larger depolarizations produce more action potentials, not larger ones. An after potential is the positive or negative change in membrane potential that may follow an action potential. Hodgkin and Huxley examined that the action potential is created by the movement of sodium ions into the cell. It shifts from potassium-dependent resting state to a primarily sodium-dependent active state. A voltage-gated sodium ion channel is a sodium ion selective channel that opens or closes in response to changes in the voltage of the local membrane potential. It mediates the action potential and stays open for only about a millisecond before the potassium ions are pushed out and resting potential is quickly restored. The word refractory refers to transiently inactivated or exhausted axonal membranes. The absolute refractory phase is a brief period of complete insensitivity to stimuli. Relative refractory phase is a period of reduced sensitivity during which only strong stimulation produces an action potential. Voltage clamping is the use of electrodes to inject current into an axon or neuron to keep the membrane potential at a set value. The apparatus measures how much current must be injected to counteract any ion channel openings. It is used by Hodgkin and Huxley with the giant squid axon. Patch clamp is a use of voltage clamping to monitor current flow across a tiny patch of membrane taken from a neuron. Conduction velocity is the speed at which an action potential is propagated along the length of an axon, or section of peripheral nerve. Larger axons allow the depolarization to spread faster through the interior. A node of Ranvier is a gap between successive segments of the myelin sheath where the axon membrane is exposed. Saltatory conduction is the form of conduction that is characteristic of myelinated axons, in which the action potential jumps from one node of Ranvier to the next. Myelinated vertebrate axons conduct action potentials faster than unmyelinated invertebrate axons. The cell membrane is made up of fatty molecules that tend to repel water. Inner surfaces of the potassium ion channel are lined with oxygen atoms that mimic water molecules. Potassium ions fit exactly into this selectivity filter. Channelopathy is a genetic abnormality of ion channels causing a variety of symptoms. TTX is a toxin from pufferfish ovaries that blocks the voltage-gated sodium channel, preventing action potential conduction. STX is an animal toxin that blocks sodium channels when applied to the outer surface of the cell membrane. Botchart-Chaud toxin is secreted by poison arrow frogs that selectively interferes with sodium ion channels. The electrical signal of the action potential is converted into a chemical signal as the axon releases a neurotransmitter. The chemical released from the presynaptic axon terminal that serves as the base of communication between neurons.